Hey guys, today we're going to talk about similar triangles. You might notice that the two triangles I have drawn here look pretty similar. In fact, these two angles are the same measure, these two angles are the same measure, and these two angles are the same measure. So since our triangles basically have the same shape but a different size, we have a small one and a large one, we call those triangles similar. So anytime two triangles share the same angle measures but different side measures, we call those similar triangles. Now, a helpful thing happens when triangles are similar, and that is that their corresponding sides are proportional. And if you think back a couple of units ago, we talked about dilations. Dilations were where we took a smaller triangle and maybe stretched it into a bigger triangle, or took a bigger triangle and shrunk it or condensed it into a smaller triangle. And anytime we did that, it maintained the same shape, but the size was different. So let's name these triangles. Let's name this triangle A, B, C, and let's name this one Q, R, S. So what angle would you say corresponds to angle A? If I'm looking at angle A in the big triangle, what angle in the smaller triangle corresponds to it? Well, that would be angle Q. They both have one mark. They occupy this kind of same space in two different triangles. Likewise, angle B in the big triangle would correspond to what angle in the small triangle? Well, that's angle R. And angle S in the big triangle, angle C in the big triangle would correspond to angle S in the little triangle. Now, not only do the angles correspond, but the sides correspond too, and the side correspondence is where we see the proportionalities come into play. So I'm going to use lowercase letters here, and opposite angle A on the big triangle, I'm going to put side A. Opposite angle C will be side C, and opposite angle B will be side B. Likewise, opposite angle Q over here will be side Q. We have side S here and side R there. Now, what side corresponds to side A? Side A and side Q correspond. Side C corresponds to which one? Hopefully you said S. And side B corresponds to side R. Now, what happens with these is we can write all kinds of proportions. We can say that side A over side B, so this side from the big triangle over this side from the big triangle, would equal, I'll see if you can figure out what two sides those would be. So the question basically is, what two sides from the small triangle correspond to the same two sides from the big triangle? So if I'm talking about side A and side B on the big triangle, then on the little triangle, hopefully you're thinking Q and R. So there's a side correspondence proportionality. A is to B as Q is to R. Now that's certainly not the only one we could write. Okay guys, so not only is this a proportion we can write, but basically you can kind of do this however you want as long as the sides correspond. So let's see if we can write another one. I'm going to come over here where I have a little room. What if I said C is to S as, so here's C, here's S. C came from the big triangle. It corresponds to S on the little triangle, so what could you write? Well, one thing you could write is A is to Q. So C from the big one is to S on the little one, as A from the big one is to Q on the little one. You could also set these equal to B from the big one over R from the little one. So there's just a little bit about similar triangles and the proportions that we could write. Now, here is a triangle. Let's call it ABC. And then notice that this side of the triangle and this segment cutting through the triangle are parallel. You can tell they're parallel because of these arrows that are placed on the lines. So whenever a triangle is cut by a line or a segment that is parallel to one of the sides, then some interesting things happen there as well. So if I called this length A and this length B and that length C and that length D, so A being from here to here, B is from here to here, C being from here to the vertex, and D being from here to the vertex. Basically, we've got us a proportion set up just like it's written. We could say A is to B as C is to D. So this side over this side is equal to this side over that side. We also could say A is to C, A is to C as, what do you think? That's right, B is to D. So a little bit about proportionality, a little bit about similar triangles, and hopefully this helps you understand how to deal with similar triangles and their proportional parts. Thanks for watching.